Hi, good morning. My name is Pete Rust. I'm an architect at HMFH Architects in Cambridge. We're going to talk about how to balance historic preservation with today's sustainability concerns and the need for emergency housing. Specifically, we're going to discuss a project that we undertook at 859 Massachusetts Avenue in Cambridge. We'll describe the challenges of updating this 140-year-old single-family house to meet the needs of 30 individuals. We'll discuss strategies for recreating lost architectural elements, and we'll review the opportunities and challenges of producing energy on a tight urban site without compromising the structure's historic character. There will be a Q&A period at the end of this presentation, so please drop any questions that you might have into the Q&A section of your Zoom screen.
And I'm Gary Brock with HMFH Architects. I'll be talking about a lot of the sustainability features in this project. There's a group in our office that really tries to bring that to all of our projects.
Hi, and I'm Charlie Sullivan. I'm director of the Cambridge Historical Commission. I guess I represent the owner, the city of Cambridge. So this building, which you see here on the left, is one of three mansards in a row that are a block from City Hall, 2 blocks from downtown Cambridge and Central Square, that were built in 1885-86 as single-family homes for urban professionals. And like many houses in urban cores, were long since converted to rooming houses or professional offices, or just plain office buildings, or allowed to deteriorate. So these three are not on the National Register. They're not designated locally in any way. They're not under the protection of the Cambridge Historical Commission, except insofar as they're more than 50 years old, and so they're subject to the city's demolition delay ordinance. So there are hundreds of houses like this in every New England city, every northeastern city, that are important for context, that may not be individually significant, that have deteriorated or been badly treated over the years, but are still recoverable and often need to be updated to modern standards. So in this case, this was a house that was acquired by the city in 2016 as temporary emergency housing for up to 30 women and children. The only historical commission involvement was the question from the city manager about whether we considered the house significant for the demolition delay procedure. And when we said that we did, the city decided that rather than demolish and perhaps subject the process to a public hearing, they would renovate the house, and selected HMFH Architects to carry out a renovation in which we participated in an advisory capacity, but not in a regulatory capacity. So with that introduction, I'll turn it back over to Gary and Peter, and I'll come back at the end and talk about how this fits into the strategy for renovation and rehabilitation of other types of houses in Cambridge.
So 859 Massachusetts Avenue was built in the late 19th century in the 1880s as a single family home. And it is located on a prominent site between Harvard and Central Square, which is sort of the downtown area of Cambridge. And the home was converted into offices at some point in the last few decades. As Charlie was saying, many of the other houses in the neighborhood from this era were converted into rooming houses or offices. This building was converted into offices and was remodeled in the process, and it lost most of its exterior detail also over the years. But the basic shape of the building has remained. A large 2-story high cube at the front of the building with a mansard roof, and then, as you can see in the photograph on the right there, a lower 2-story high portion with a flat roof. The front entrance had been completely rebuilt at some point with with that brick stoop, as you can see in the left-hand photograph, and a new entrance down to the basement level right next to it. So as also Charlie was saying, the city of Cambridge bought this property in 2016 with the intention to convert it into emergency housing for city residents, and HMFH was hired as the architect for that conversion. So our client was the city of Cambridge, but the facility is actually run by the Cambridge YWCA. Here's a photograph of some photographs of the interior of the building before the renovation took place. As you can see, some of the original details were remaining, but the floor plan had changed significantly. The original stair remained in place, as you can see there on the left. Next, Gary. Here's a map showing the general location. The YWCA has renamed the facility as Renee's Place. So we'll be using that name to refer to the project. It's synonymous with 859 Massachusetts Avenue. And you can see there that Renee's Place is located near all of these social services and stores and public transportation. So it's a great place for emergency housing. So the goals for this project are divided into three basic categories: programmatic goals, sustainable goals, and historic goals. The programmatic goals, the main programmatic goal was to provide temporary housing for up to 30 people, specifically families, parents, and their children. And because of the population that this facility was serving, it was very important that we maximize the occupants' privacy and also their security. We also had to provide an accessible first floor. The building was not accessible at all before. And we were asked to provide communal spaces for social interaction, including communal kitchens and dining areas, play areas, and meeting spaces, and a laundry. And we also had to provide an on-site management office for the YWCA.
So the sustainability goals, we were trying to meet the Cambridge's effort to meet net zero greenhouse gas emissions, and they had their climate plan and net zero plan in effect. And we were basically approaching this as a deep energy retrofit and trying to maximize the energy performance as much as we could. And as you've seen from the photos, it's a very tiny site. So being able to produce renewable energy on site was going to be fairly limited. So we were trying to bring our consumption down as much as we could, in an effort to try to get as close as we could to that net zero goal.
And our historical goal was really quite simple. It was to recreate the building's original appearance as closely as possible while still accommodating its new function. And we'll talk more about the sustainability and historical goals in a few moments, but first I'd like to go through the program a little bit. Here's a site plan of the finished project. Massachusetts Avenue runs along to the left there, and then Clinton Street, which is a smaller side street, is running along to the bottom. As you can see, that basic shape remains with the large cube fronting Massachusetts Avenue with the mansard roof, and then a lower two-story high portion at the back of the building. We added a small addition along the Clinton Street facade and provided a new entrance. We also added a small private enclosed outdoor play area right at the back of the site, and 2 parking spaces for staff. The major change we made from a site standpoint is that we relocated the entrance. The original entrance was located on Massachusetts Avenue. We relocated the entrance to Clinton Street with access via a ramp. And we did that to provide some privacy for the residents and also to provide an easier accessible route. So the entrance on Massachusetts Avenue remains, but it's now just a secondary entrance. Next, Gary. And here are the floor plans. The basement floor plan, or the lower level, is in the lower left-hand corner, and then first level above that, second level in the lower right, and then third level in the top right. So the first level, you can see that the original entrance on Massachusetts Avenue over there to the left is remaining, but the new entrance is along the south facade with that new ramp. The area that's highlighted in yellow is our new addition. As you can see, it's a very small addition. So you come into the entrance at the first level. There's a playroom just to the right, which opens out onto that enclosed outdoor play space. There's a small office, and then there are 3 bedrooms on the first floor. So as I mentioned, this facility was designed to house up to 30 people. There are 10 bedrooms in the facility. Each bedroom is designed to house 3 people, typically a parent and 2 children. Each bedroom has its own private bathroom and its own refrigerator. But when the residents cook their meals, they use the communal kitchen, and there is 1 communal kitchen on each floor. So you can see in the first floor plan there, the communal kitchen is in the upper left-hand corner. And then right next to it is a stairway that brings you up to the second floor. On the second floor, there are 5 bedrooms, again, each with their own bathrooms and refrigerator, and there's a communal kitchen on the second floor. And then up at the third floor, there are 2 more bedrooms and a communal kitchen, along with a small living room, which is accessible and usable by everybody in the building. And at the lower level, there is an office for YWCA staff, some storage, and a laundry room. And there's actually 2 laundry rooms. There's one in the lower level, and then there's a accessible laundry room on the first level. Next, Gary. Here's a section cut through the finished project. And again, you can see that the basic shape of the mansard roof and the front of the building and that lower 2-story high portion at the back of the building is still intact, also in section. This section also shows the proximity to Massachusetts Avenue, which is a busy street, and the Red Line subway, which runs directly underneath Massachusetts Avenue. So we were very cognizant of the noise that could be coming into this facility from the exterior. We also had to be very careful with noise transmission from one interior space to another, because since this building was built for a single family, but is now housing potentially a few dozen people, the chances for noise going from room to room were very high. And we felt that in order to maximize the residents' comfort and sense of privacy, that mitigating noise between interior spaces was very important. Fortunately, the methods that we would use for combating noise transmission coincide with the methods that we would use for increasing the thermal envelope on the outside of the building. So Gary will talk a little bit more about that in a little while. Next, Gary. So because the new program for this building and the deteriorated state of the building, because the new program was so different from the existing program, it was decided very early on that this was going to be a gut rehab. And while in general, gut rehabs tend to be more work, they also allow a lot of opportunity to upgrade all of the existing systems in the building, to reconfigure the thermal envelope on the outside of the building, and really make a deep energy retrofit feasible. So that's what we did. And in these photographs, you can see the building after demolition began. You can see the shape of the mansard roof on the left-hand side there. Next, Gary. And of course, you can see some of the other details that we uncovered, including areas of rot or deteriorated or missing bricks at the foundation, and all of that had to be repaired. And now I'm going to turn things over to Gary, who's going to talk a little bit about the sustainable features of this design.
So thanks, Pete. Pete's already mentioned the exterior envelope, and there are a lot of things that went into improving the exterior envelope that are of interest. And a lot of this is what's currently happening on a lot of passive house projects today. We actually explored getting certified as a passive house project, but it wasn't something that the owner was asking for at the time. And we weren't 100% sure we would be able to achieve it because we weren't excavating around the building to fully insulate the foundation on the exterior. But we did get pretty close to doing everything. We did insulate under the slab. We had to remove the slab, put a radon mitigation system in, and added insulation there, as well as extensive insulation in the envelope. And the envelope has continuous insulation on the exterior. You'll see some photos of that being built, of mineral wool, 6 inches of that. And then the stud cavities were also filled with blown in cellulose insulation. There are 2 air barriers, one on the interior that is a smart vapor retarder. That also helps keep the cellulose insulation in place. And then there's vapor permeable air barrier on the exterior. It's also the water barrier. And then this gives you a good sense of how we tried to maximize renewable energy on the project. There is 2 types of PV systems. Number 1 is actual building integrated PV, where those PV arrays are actual roof shingles. So we displaced the asphalt shingles for that upper part of the roof with some PV panels. And because of the orientation of the building, each side of that roof actually gets solar exposure because south is kind of on that diagonal corner. And then the flat panels, we took advantage of the enclosure we were building up at the 3rd level to house some mechanical equipment to also support some solar thermal to be a boost for solar hot water, and a larger array that could expand over the whole roof. And much of this was not very visible from the street, so it was pretty discreet as well. And then just one other side note, we explored using geothermal in conjunction with a VRF system here. The city was interested in exploring some different well drilling options. It ended up not panning out for this project, so we still went with an air source VRF system. And one other side note about this that affects cost paybacks, this particular area of Cambridge, the utility grid does not allow you to export. So Cambridge can't take advantage of the net metering that you'd normally do with PV systems. So it still is, and we didn't do it at the time, but it's a good project to consider using battery systems. So anything that you're producing above what you need can actually be stored for later use. But as we've described, it's already a fairly dense project as far as use and consumption. These are some wall sections that give you a sense of what was there originally and what we added on to increase the thermal performance of the building. Up above, we also did this around the whole envelope, increasing the insulation at the mansard. We replaced the slate roofing that was in some disrepair. Pete will talk about that a little bit more. Another oddity that we had to deal with on this project is because of the tight urban site, adding that extra insulation on the exterior wall at the, I guess, west, north, depending on your orientation, with the abutter, that was going to push the envelope beyond the setbacks. So we actually had to treat that side of the building differently. We couldn't add as much exterior insulation outside of the sheathing. I think the Cambridge has now adjusted some of their ordinances to allow for that kind of extra insulation, even if it is encroaching on the setback. This gives you an example of, again, modifying the details and trying to keep a similar look as to what was there before, but keeping that thermal barrier continuous around the whole project. And again, this is the mineral wool insulation on the exterior. You can see one air barrier on the left, and these are some thermally broken Z-girts that help reduce the conductance through the exterior wall. And the mineral wool actually was heavy enough that we had to run these girts vertically instead of horizontally, which we more often see and do just because of the flexibility in installation. But installers do it both ways, and it worked well with this thicker insulation going vertically.
But it did complicate things a little bit in that we had to align these vertical girts with the vertical studs on the other side of the sheathing.
Yes. Windows, we went with Passive House certified windows and exterior doors to also get as good as we could on the energy performance. And we were also trying to keep it sympathetic to the double hung windows that were original to the building. These are in-swinging casements. So the bottom part is operable. In this case, we got windows that were manufactured by Zola. So they're wood windows, aluminum clad on the exterior for better long-term durability. And I think the next slide shows you. We'll get to what they look like on the inside, but these higher energy efficient windows are being explored on other projects. I heard about a project in Fitchburg that uses a similar window, and that has National Park Service reviewing that, and it looks like they may accept it. And that's a different manufacturer, but very similar type of window. And then in tight locations and in the basements, we use some spray foam insulation as well. And this is the windows and their in-swinging capability. So, on the left, it's closed. In the center, it's actually vented open. So it tilts at the top, and on the right, it's fully open. So you can clean it and get plenty of air. And this is just a photo from above, giving you a sense of where the renewable systems are installed and how we got those to work with the building. There's also mechanical ventilation in the building, so we have energy recovery as well. So that's tucked away, and that's also why there are those funky goosenecks up at the top of the roof. I think I'll hand it over to Pete now.
Thanks. The historical goals for this project were quite simple: to recreate the building's original appearance as closely as possible while still accommodating its new function. This project, or this building, first appears on the tax rolls in 1885, and the basic shape of the building has remained intact throughout its history, as have its window locations, which was lucky for us. We didn't have to recreate that or rebuild anything to bring the structure back to its original form. But almost all the original detailing had been removed at some point during the building's history. We did have a few clues to go on as to what the building used to look like. We had that. Actually, Gary, could you go back one slide, please? So this photograph is the only photograph that we were able to find of this property. It was probably taken in the 1930s or 40s, showing a long row of similar mansard roofed houses along Massachusetts Avenue. Our project is the one that is highlighted in yellow. A few of those other buildings have since been torn down, but you can get an idea from this photograph what the building used to look like, including the original front porch that was located at the main entrance. Next, Gary. This project is not located in any historical district, but it is located only one property away from the Mid-Cambridge Neighborhood Conservation District. And that district includes dozens of houses that were built at the same time in a similar style, French Second Empire style. So we were able to look to these neighboring buildings as precedents for our project. Next, Gary. And there were some original architectural elements on the exterior of the building that were, that were still there. The original granite foundation, which you can see on the left-hand side there, the foundation is built of these very, very large granite blocks. There was a small porch located near the rear of the building that was still somewhat intact, and you could see its original brackets and cornice, although obviously that column was replaced at some point or another, and the fire escape was installed. The original slate roof remained, and the original dormers in the mansard roof remained, although they were in terrible shape and were not salvageable. You can see that on the right-hand side. Next, Gary. But when we started to demolish the building, we were presented with a lot of clues that really helped us. When we took the aluminum siding off, the original siding was still there, and all of these sort of ghosted silhouettes remained of the original decorative trim that was on the outside of the building. So in the upper left-hand corner, you can see the location of a hood, sort of a decorative hood that was located over one of the first floor windows. On the lower left, you can see underneath the roof cornice and the locations of the original brackets. On the right-hand side, you can see the outline of a smaller secondary cornice that wrapped around one of the bays. Next. Here's some more examples. These were taken where the original front porch over the front entryway intersected with the front facade. So when we went into this project, we thought that some of these elements might be visible underneath the original siding. So we designed the project with I guess we could say placeholder details. And then once demolition began, we refined those details by measuring these shapes and adjusting the proportions of our details accordingly. Next, Gary. We worked with the city of Cambridge, the Cambridge Historical Commission, both on that exterior detailing process and on the paint color selection process. When we first started thinking about paint colors, we were a little bit off base as to what this building might have been painted originally. The image in the upper left, I think, is the first image that we sort of came up with showing paint colors. And we went through a few different options, and the Cambridge Historical Commission explained to us that typically buildings from this period were painted with darker, deeper colors, typically one color for the trim and then one color for the clapboards. So that's the idea we went with, and together with the Historical Commission, we developed the color palette that we ended up using. Next, Gary. So here's the finished project. The Massachusetts Avenue facade is on the left, and the Clinton Street facade with its new entrance is on the right. There were some spots where we had to reconcile our historical goals with our programmatic goals and our sustainability goals. As you can see in the upper right-hand corner, well, you can see where the new entrance is and our new addition is. The shape of the mansard roof carries over onto our addition, and it provides a good orientation for our solar thermal hot water collectors, which are those 4 panels you can see mounted to the roof up there. And the original addition was actually going to be a little bit larger, but for reasons having to do with zoning, we weren't able to build it as large as we liked it. So it ended up getting cut back, which means that those solar thermal collectors aren't visible from Massachusetts Avenue. So that kind of helps keep the original appearance of the building a little bit more intact from Massachusetts Avenue. But as you approach the building from Clinton Street, you can see those solar thermal collectors, which is also in its way kind of nice because it sort of advertises the sustainable technologies that we've included in this project. Next, Gary.
Just to add a little bit to this too, the fenced area that's behind the guy that's walking up the ramp is where the condensers are located. And we were happy that initially geothermal was going to be considered because there wasn't a lot of space on this project to put equipment like this. And we were trying to build the canopy above for the PV system, and we had other things coming up through the roof, and there'd be loads if we had to put mechanical stuff on the roof that might impact structural requirements. So it was kind of late in the game when we had to switch, and it turned out that it worked out fine. We were able to find a home for it, and it also was not a loud piece of equipment, so we didn't have to worry about that. And on the energy efficiency side, it actually ended up being a hair more efficient. So we didn't really lose anything either on that trade-off. So it worked out fine in the end.
Another location where we had to reconcile our sustainability concerns with our historical concerns had to do with the addition of this extra layer of insulation on the outside face of the original cladding. Because we installed insulation at all of the exterior walls and at the roof, it's basically just like putting a big winter coat over the whole building. And this changed the original proportions. And it's not particularly visible, but it is clear in some spots that the composition of the exterior is different than on some of the other buildings in the area. So, for example, where this new layer of insulation meets the original foundation, there's an overhang of about 6 inches, and that is not typical for a house from this time period. Those 4 photographs on the left are all taken in the neighborhood, and they show that the relationship between the exterior facade and the face of the foundation is one in which they pretty much align. They're they're both in the same plane with each other, but we didn't really have that option because we were adding this insulation to the outside face of the exterior walls. And in this view, you can also see the spray foam insulation that we installed on the interior side of the foundation. So right down at the bottom of that drawing is the granite foundation with the brick backup behind it, and then just inside of that is the new spray foam insulation that we installed throughout the basement. Next, Gary. Another place where the proportions of the exterior changed due to this new layer of insulation is at the bays. Because we added this new layer, due to the geometry of the bays, it made the window openings grow further apart from each other. And we were able to mitigate that a little bit by increasing the width of the windows. We took up the space of the weight pockets that were originally there. The weight pockets were taken out, and the width of these windows at the bays grew a little bit. But there's still sort of a rather large blank area, I would say, between the new window openings at the bays. And I think if we were gonna do this project again, we'd look a little bit more closely at adding another detail element there. Of course, originally the building, might have had shutters, and it might have covered up those areas of the facade. Next, Gary. The city of Cambridge was very concerned about maintenance, and we were asked to minimize the use of wood on the exterior. So we did use other materials. Most of the trim is actually cellular PVC, painted cellular PVC, and most of it is standard shapes that, so we didn't, there weren't a huge number of custom pieces. The brackets underneath the cornices were custom, and the brackets that support the canopy over the original front door, which you can see here, those are actually painted wood because they needed to have, because they needed to be structural to support the canopy. Now, originally, this building did have a full-size porch on the front of it. And it was felt that if we rebuilt that porch, that it would compete a little bit with the new entrance located on the Clinton Street side. So instead of rebuilding the porch completely, we simply designed a new canopy that is supported by these brackets. And that's not unprecedented for buildings of this time period and in this neighborhood. So we felt that that it would be okay to do that. The siding is also not wood. The siding is made by a company called Boral, and it is 70% fly ash, which is a byproduct of the burning of coal. And the decking that you see on the right-hand side, and that's that photograph of the stairs, the decking is wood, but it's undergone a process called acetylation, whereby the water is extracted from the wood and replaced with a mild acidic solution. And it keeps the wood from rotting. It keeps it from expanding or contracting or warping. And this is the only opportunity we've had to use this product so far in our office, but it's something that that's very interesting, and it's something I would like to have the chance to use again someday. And so far, it's worked out very well on this project. Next, Gary. Here's a photograph of the original roof on the left and the new roof on the right. We had talked about possibly saving some of the slates and reusing them, but we would have had to have removed all of them anyway in order to install the new insulation at the roof. So we decided that since the roof was already 140 years old, that it would probably be a good opportunity to replace the slates. So the old slates were replaced with new slate. Just a quick note about the interior. Obviously, all the new interiors were new. All the partitions are new. We kept things very simple. Pretty much all the spaces are treated the same way in terms of materials and colors. We did repurpose this one original stained glass window that was originally located at the stair and has now been relocated adjacent to our main entrance. Next, Gary. So here's the finished project. I think a few things that we kind of learned in the process, two things that really stood out for me was, as Gary said, we had very limited space for photovoltaics on this site, even more limited by the fact that we kind of we did want to conceal them a little bit from the street so they weren't so visible. And also because this building was built when it wasn't really designed for the amount of ductwork that we had to install in the building. So we had to be very careful about making sure our ceiling heights were adequate while still providing enough space for ductwork. And that was a major challenge. Gary, I don't know if you have any other comments about this.
Yeah, I think another thing that is true of any project, the relationship with the owner, and in this case, the owner was the city of Cambridge, even though the Y is the one that's essentially operating it and occupying it. So there are different players involved and different people that you're dealing with, and sometimes some communications don't get all the way through. So it's important to try to communicate with everyone, especially when you're doing a really energy efficient project. How that building gets used afterwards has an impact on its efficiencies. So, and we're all in the design world, whether it's dealing with something that's more historic or something that's very contemporary and new, trying to, predict our energy performances now. We're trying to be accurate with it, but many times it's going to depend on the owner and how they use it. So our prediction for this building was essentially like an 87% reduction. We had a 17 kBTU per square foot energy consumption predicted, and it ends up being double that. And it could be other reasons for that. So the reduction is over 60% in actual measured use, which is still significant given the tight constraint and the density of the use. I mean, we've got a dozen refrigerators, laundry, and 24/7 use of the building. So we think we still did a good job with that, but it's also something that is important for the design team to work with folks in the turnover and how they use it. I think the city does a great job still maintaining this helping them maintain it. So that helps on the energy efficiency side as well. We look for really high efficiency appliances, so we did the best we could. Refrigerators, we used induction cooktops in the kitchens, and we initially used heat pump dryers. One of those got switched out for one reason, so that also has an impact on energy consumption. But these are all new things too for people to get used to using, just on the operational side.
And I'll just say that the City of Cambridge's net zero action plan predicts that 22% of the city's overall reduction in greenhouse gases will come from residential retrofits, and 29% will come from commercial retrofits. So I think that projects like this, deep energy retrofits of existing buildings are just going to become more and more common over the next few years. With that, I will turn it over to Charlie.
Okay, so honestly, I think this project was a home run. It preserved a building that had been highly compromised, that when I had to tell the city manager that I thought the old Chamber of Commerce building was significant under the definition under the demolition delay ordinance, I sort of was taking my life in my hands, because I wasn't sure that anyone would take it seriously. It was so badly degraded. But the city stepped up to the plate, as they've done so many times before. And from then on, I had an advisory relationship with HMFH and the city's development team. So we were consulted on many of these details. I think the project followed many of the procedures that we recommend to homeowners and anyone owning a house that has been treated as this one has. And that is in planning an exterior restoration or renovation, don't design the details in advance, because they will demonstrate themselves to you when you take off the siding. I've never seen a building in which the original siding was removed when artificial siding was installed. So in every case, the clapboards are left and they provide a sort of a shadow outline of the original details. And those can make all the difference in the credibility of a rehabilitation project. We just sort of know intuitively, many of us, that when the width of a corner board is correct and when it's been faked, or when the panel details on a bay window are correct, and when the architect or probably the carpenter on the job kind of made up those panels, and they don't read. They just don't work well. Windows are always another flashpoint in these conversations. And I think this is a pretty good, an excellent example of how high efficiency replacement windows can mimic original windows. These replicas of double hungs are quite convincing. They're not perfect by any means. We can nitpick about any of these modern manufactured replacements, but in the larger context of things, they work extremely well. So we have developed some of these practices. The Cambridge Historical Commission, working with Cambridge's affordable housing agencies, and applied them in numerous instances where we use CPA funds for historic preservation to assist affordable housing projects, many of which have been projects by the nonprofit agencies that are our partners, where they're doing deep energy retrofits like this. And in many cases, the building is not in as bad shape, hasn't been treated as badly as this. If there are significant exterior details, window trim or big decorative panels, those can be preserved, but adding exterior installation is a given of in the current environment for any sort of serious rehab projects. Also, we're dealing with affordable housing projects. So it's easier in some cases to generate capital funds for renovation, but ongoing maintenance can be a real burden to the property owner, the affordable housing agencies. So that plus the often expired life of exterior details and trim sort of points you towards the use of artificial materials as such as the boral siding and the PVC trim and brackets in this case. So I think, you know, purists, and I'm often a purist, can cringe at some of these applications of new materials. But in fact, if we're promoting social housing of whatever variety like this or affordable housing and preserving the character of neighborhoods in which the buildings may not be individually particularly significant, but reinforce each other and are important in their context, then I think these are choices that face us all the time in our older cities. So thanks for the prompt, and I'll open the Q&A session. So if you have more questions, that's how to reach us and use the Q&A function, not the chat. So I'll take these more or less in order. We have one comment that 30 people is surely more than lived in this house when it was first built, but most historic homes of comparable size probably house many more people than a single family, as exclusionary zoning has defined that term. Adaptively reusing these homes as multifamily housing seems appropriate in multiple ways, socially, environmentally, and historically appropriate. Thank you for that. Then we have, oh boy, I see a note saying, reminding us there's no hard cutoff, so we can take our time with Q&A and go as long as we want, except for lunchtime. So someone asks, within reason, is the note, how accurate is the argument to the effect of it is much more costly to preserve or retrofit an historic building rather than tearing down and building new? Gary and Peter, that's for you.
That's a constant question.
I think it depends on many factors.
Yeah, it depends on what you're dealing with as the original and how much work it's going to take to bring it back to life and how well it meets the needs for the new uses. I think there is a concerted effort because buildings are becoming so much more energy efficient that everyone is starting to look at the embodied carbon associated with existing buildings. So, you know, tearing it down and replacing with something new in the carbon equation may not be great. So you're going to have to weigh all of these, you know, questions. And, you know, we try to help the owners make the right, you know, whatever the right decision is for them. But we do think that rehabbing existing is going to be much more important going forward.
Yeah, there's sort of a social balance sheet exercise you have to go through. There's obviously the costs of the alternatives, but there's also the relatively unquantifiable or completely unquantifiable issues like embedded energy and the social value of preservation, of preserving these buildings that contribute so much to the character of our communities. You know, and beyond that, there are political issues involved. Cambridge has moved very strongly towards not only energy conservation, but production of affordable housing. And so in some cases, demolition might weigh more heavily in the balance when you consider the possibility of increasing the supply of affordable housing. So those are values that differ in different communities and have to be taken into account.
Just you know, on this project, it was never just tearing down the building was not discussed. It's possible the city of Cambridge discussed it, but not. It was not. We weren't part of that. If that discussion actually took place. So it would be hard to say exactly what the replacement cost of this building would have been if it had been torn down. We're actually working on another project right now, also in the city of Cambridge, where we are renovating an existing building and building an addition that will almost be the same exact size as the renovated portion. And we're going through a cost exercise right now, and it's comparable. The cost of renovating the existing building is comparable to the cost of the addition. So, but of course, there are non-financial costs associated with tearing down an existing building and rebuilding it. So,
yeah, and that discussion did occur before you guys were brought on board. When the city manager's office asked if we consider the building significant, and I said that we did. And after some extended discussion, they agreed to go with a renovation alternative. Peter, here's a question for you. What materials are used for the mansard roof behind the main block and for the wall below the thermal panels on the second and third floors?
the walls underneath the thermal panels, that was a zinc roof. So a standing seam zinc roof, and the solar thermal collectors were attached to that roof. And underneath that roof, we had I think a plywood sheathing, and then an airspace, and then our insulation underneath that. And I'm sorry, what was the first part of the question?
That was it.
Oh, okay.
I think you answered that.
That was it. Yeah.
Okay.
What was the material was used for the mansard behind the main block?
Oh, yeah. Yep. Okay.
A related question was, how did the integrated solar work with the new slate? Could that have been done if the old slate was reused?
Oh, sorry, go ahead, Gary.
Yeah, no, go ahead.
The integrated photovoltaics were installed at the upper portion of the mansard roof, and that portion of the roof was just clad with asphalt shingles. Slates were only used at the lower part of the mansard roof. So the integral photovoltaics and the slate actually were not installed in the same locations.
And just a note on building integrated photovoltaics is something that people have been working on for a long time, but it's really hard to get the right products. And in publicly bid projects, it's hard to find three equals. So sometimes it needs to go out proprietary. There's got to be conversations about that, but it is sort of a desire for the architecture community to integrate these things when we can, when it's appropriate, and it can help offset some of the costs. Hopefully that's the intent as far as other materials.
So hypothetically, you could integrate those solar materials with a slate roof?
Hypothetically, and there have been some experimental products created that never really, I think, had commercial success, where there have been some that look like the Spanish clay tiles and, standing seam. They look like, so it's just really esoteric stuff that people are trying to create and Tesla's trying to create, but hasn't made it to market. So there's a lot of this stuff coming in the future, hopefully, but it's not there yet.
Okay, I'll give you a break and I'll take a question. Can you talk about how the Historical Commission might have responded to this project if it was in a local historic district or conservation district? That's a really good question. What distinguished this property was that it was not designated, and it was for social housing, which is a different condition than properties in our historic districts, which tend to be in fairly affluent areas owned by owner occupants, and where our historic districts, I mean, perhaps more than most communities, are major historic district includes buildings from the 18th century through the late 20th century, almost all of which are high style or architect designed structures, expansive structures on large lots. And in our historic district, where we do regulate materials and colors as well as appearance, I think some of these changes might have been a stretch. We might have urged owners to find other ways to achieve energy goals, but this is a moving target and an ongoing conversation. I mean, we're in our historic districts, we're accepting synthetics now in certain situations, such as porches or balustrades that are outside the protection of a roof. And we're accepting fiberglass gutters as a replacement for wood, where they replicate the appearance. And so, you know, I think this is going to be a moving target over coming years. In the conservation district, the standards are a little less rigorous. And so I think, I think this project ultimately would be approved in both cases, especially if this social housing project were on Brattle Street in our historic district, the social housing aspects of it would be compelling. And certainly the quality of the exterior renovation in terms of replicating exterior details is compelling also. So I guess, I'm kind of making up this answer as I go along, but I think ultimately it would have received a certificate of appropriateness. So back to you guys. What were those percentages of carbon emission reduction from residential and commercial retrofits again?
The city of Cambridge anticipates that 22% of the reduction in carbon emissions will come from residential retrofits and 29% from commercial retrofits. But I believe those statistics are just for the city of Cambridge. They're I think it depends on where you are, but for the city of Cambridge, that's what the numbers are.
Okay, next one. It's a beautiful project. It was serendipitous that you were able to recreate the historic details on the new facades, but in most cases, it's not feasible or approvable by historic district commissions to add 6 inches to the outside of the wall. It is feasible to get reasonably close to net zero with more traditional retrofit techniques, wall insulation, higher performance window openings. I'm sorry, is it feasible to get reasonably close to net zero with more traditional retrofit techniques, wall insulation, higher performance windows, et cetera?
I would say, yes, it depends. Again, it depends on the use and what's going on in the building and how much production of energy you can create. And it also gets into, semantics about how you define net zero and stuff like that too. So, but in general, I would say it's feasible to get very close to net zero, if not net zero. I think it's possible. But again, it depends on the use and the size of the building.
And quickly, a related comment. Based on details provided, it would seem that this project would not meet the Secretary's standards for rehabilitation. You think it's not possible or perhaps too difficult or expensive to do a deep energy retrofit and meet those preservation standards? Gary, that I think responds to your comment about the Fitchburg project.
Yeah, so it's not one of our projects, but it was a session I was listening to where there's 2 historic buildings bookending a new building in the middle. It's affordable housing, and they're working with the national parks on a lot of the details there, and it includes the windows. So they're getting windows from a company out of Cambridge, still importing the windows from Europe, but it's a similar style window. The company they're working with is Yarrow, I believe. But there are things that you can work with. Saw a presentation yesterday at this conference where folks were doing really good energy efficiency on some old mill buildings too. So it depends on what you have to work with. And, so if it's a masonry building, if there's plaster on the interior, I hear that you have more leeway to do things with insulation on the interior than if it's a lot of exposed brick, and how the historic agencies allow you to go beyond what was there. So I think that what you're starting with has a big impact on that.
We only have a couple of more, so I know it's 12, but we'll keep going for a few minutes. Why did you extend the walls outward rather than inward to accommodate the insulation? Were you willing to sacrifice historic accuracy for square footage?
That's a great question. It was because we didn't want to sacrifice the square footage on the interior. Some of the bedrooms are really quite small as it is, and we didn't want to give up any more interior space if we didn't have to. That was the main reason.
We were also trying to accommodate, they were moving to another facility, so we were trying to keep it as close to having the same amount of usable space that they had at the other facility.
And I think the calculation might have been different if the original details on the exterior were still in place. Because they had already been removed, it seemed like there was perhaps less on the exterior that we had to save.
That's a really good point. Can you say what the total cost of this renovated, what was the total cost of the renovated reused building, and how was it funded? So I think this was funded through the city's capital budget, but I'm not aware of the cost.
It was the total cost was $4.6 million. And I don't know what that, or I can't remember what that comes out to, the cost per square footage. I want to say, well, I don't want to mislead people. Yeah, so but I believe it was about $4.6 million total cost.
So that probably indicates a pretty substantial per square foot cost.
Yeah, somewhere between $500 and $600 a square foot.
So Cambridge the city of Cambridge is fairly well off with our famous tax base in Kendall Square. So this kind of expenditure might not be feasible in many communities, but I think there are areas where, perhaps this could have been a less expensive project. The geothermal aspect was tried. I think there were 2 separate drilling programs, both of which failed for technical reasons. I'm not sure if that gets folded into the project cost. But geothermal is a major expense, and it's really been a dodgy proposition in Cambridge, with a number of failed wells and a water quality and a corrosive water quality that has impacted the efficiency of some of the equipment. So there might have been features of this project where it could have come out with a lower cost.
The geothermal wells were not included in that base cost. They were separate.
Okay.
Yeah.
Good to know. And then finally, the last, there's a comment that Mass Audubon's Boston Nature Center has some integrated photovoltaic roof shingles that were installed over a decade ago. And we don't know how they're working out, but that's a precedent. And if you go to the Mass Audubon website, go to the Boston Nature Center page about climate action, solar energy, you can learn about that. So that's the end of the questions in the chat. And I mean, in the question and answer session. And I think that's about what we have to say. So on behalf of the city of Cambridge, thanks for tuning in. And I hope we can continue this conversation in the future. So
Yes,
Gary and
we
Peter,
enjoyed it too.
thank you very much.
Thank you very much.
Thank you, Charlie.
Okay, so long.
All right,
Thank you.
bye.
Bye.